So here we are, page 9 of your notes, where we put it all together. So again, we're going to go over and kind of look at the different angles, and we're going to look at what their terminal points are based on what we've done. First one I want to do is the quadrantals. I have 0 or 2 pi here. Up here I've got pi over 2. Over here I've got pi, and then this is 3 pi over 2. So what we did on the first page for these points, 1, 0, 0, 1, negative 1, 0, 0, negative 1. Because again, we're working with the unit circle, which is centered at 0, 0, and has a radius of 1. The next thing we did was the pi over 4s, and those are midway. So there's my pi over 4. Remember, pi over 2 was yet another pi over 4. So then I come 3 pi over 4, 4 pi over 4, 5 pi over 4, and 7 pi over 4. And those are the ones right in the middle, like 45 is right in the middle. Actually, I don't like where those are. Let me put them on the inside so that we can put all the nice little points on the outside. I think that's what I'm going to like. So, pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. Miss Coy, where are you getting these numbers? Yeah, I'm looking back at my pi over 4 page. What was that? Page, I don't know, 6 maybe? Something like that. But pi over 4, remember, is essentially halfway to pi over 2. So I just kind of go to the halfway point on each little quadrant, and we kind of go from there. And if you recall, the numbers that I used for the pi over 4s were root 2 over 2 and root 2 over 2. That's kind of nice because for the pi over 4s, you just have to remember one set of numbers because both x's and y's are the same. Remember, when I get into this quadrant, my x's will be negative and my y's will be positive. When I come down to quadrant 3, they are both negative. And when I get to quadrant 4, my x's will be positive and my y's will be negative. So, sorry about that. I had something go off. Okay, so this is root 2 over 2, and this is negative root 2 over 2. So that's all the pi over 4s. So there they are, the pi over 4s. Same number for both the x and the y, and again, your quadrants will tell you which is negative and positive. Then we did, what did we do next? The pi over 3s. So I had a pi over 3 up here. I had a 2 pi over 3 here, and the pi over 3s tend to cluster near the top. Oh, that's 2 pi over 3. This is 4 pi over 3, and this is 5 pi over 3. They tend to cluster up towards the pi over 2 and the 3 pi over 2. They're sort of up there at the top and down there at the bottom. And when we were looking at the pi over 3s, we wound up with 1/2 root 3 over 2 for all of those. And again, you're going to want to just simply change your signs depending on which quadrant you're moving through. As you can see, all of my x's in the same quadrant are the same sign. All the y's in whichever same quadrant are the same sign. So there's the pi over 3s. And then last but not least, I've got all my lovely pi over 6s. This is 5 pi over 6. This one was 7 pi over 6. And this was 11 pi over 6. Again, Miss Coy, where the heck did you get these numbers? Looked back at my pi over 6 page, which I think was the page right before this one. Pi over 6, same two numbers as pi over 3, but switched. So root 3 over 2, 1/2 is now what you'd be doing. And this again with a negative x and a positive y. And these we have both are negative. And over here the x is positive and the y is negative. So That's how we go around. This looks like an awful lot of stuff to have to deal with. It does it not? It does. The quadrantals are actually not too bad because you're thinking you're just moving one out in each direction for the 2 pi, the pi over 2, the pi, 3 pi over 2. Those aren't too bad. It's what's going on at all the pi over 3s, pi over 4s, and pi over 6s that you're kind of like, I have to memorize all these? What the heck? It's actually a little bit simpler than you think. We use this thing called a reference angle to do this. And what the reference angle is going to do for us, it's very, very lovely. What the reference angle does is it means you just have to know the point for pi over 3, pi over 4, and pi over 6. If you know which quadrant you're in, and you know that the reference angle is pi over 3, pi over 4, or pi over 6, you know where your point is. And you don't have to memorize the whole circle all the way around. You just have to know pi over 3, pi over 4, pi over 6. That's the only points you really need. The way your reference angle works, it's the smallest angle that the terminal side will make with the x-axis. So in the first and second quadrants, what you're looking for in a reference angle is you are looking for from the terminal side of the angle to the x-axis. That's what you're looking for. That's the reference angle. How far am I going from the terminal side to the x-axis? And actually, in the first quadrant, it's basically whatever the heck angle you've got. That's really it. And reference angles will always be between 0 and pi over 2. Anything between 0 and pi over 2 is going to work. So what do you think you're going to be using for reference angles most of the time? Pi over 3, pi over 4, pi over 6. Absolutely, positively. When you get down to the third quadrant and the fourth quadrant, and you're sort of on the bottom of the circle, you wind up looking, again, you're looking for the distance between the terminal side and the x-axis. You never do a reference angle to the y-axis. It's always how far am I from the x-axis. That's what it is. That's what it's from. So I've got that. And so if I look up here and I look for reference angles, like my reference angle for, say, 11 pi over 6, right? 11 pi over 6, well, that's just pi over 6 away from the initial side, away from the x-axis. So essentially, if I'm looking here, this is a distance of pi over 6. That's how far away I am. 2 pi minus 11 pi over 6 is pi over 6. That's the reference angle. So, and you'll notice when you look at the x and y coordinates, they're the x and y coordinates for pi over 6. Change the signs a little bit because the quadrant is different, but that's essentially what you're doing there. So I believe that is page 9, and then we're going to move on to page 10 where we discuss the reference angles a little bit more. And don't worry, it's not terrifically complicated. You're going to see that on the next page. So hold on, and here we go.